Alright, so the next thing that you need to learn on subtopic 7.1 is about dissociation constants in terms of acid ataupun base. Okay, basically dissociation constants ni dia punya simbol dia sama macam equilibrium constant. But in this case, dekat chapter 7, kalau K itu adalah dissociation constants. Okay, I believe that bila you belajar dalam subtopic 6.2, kita anggap K ni sebagai equilibrium constant. Okay, tapi kalau dia kat chapter 7, if you nampak sahaja K, itu adalah dissociation constants. Cumanya kenapa ada huruf kecil A dengan B kat sini, because it can be for acid ataupun base, tapi specifically weak acid ataupun weak base. So that's why Miss bagi tahu kalau nak cari pH untuk strong acid dengan strong base sangat berbeza dengan weak acid dengan weak base. Okay, and then next, bila you nak calculate any items yang melibatkan Ka atau Kb ni, you need to do a rise table. Okay, because from the rise table, okay, you boleh dapat the value of concentration of the weak acid ataupun weak base. It depends lah. Kalau let's say acid, you akan dapat concentration of H3O+. Okay, kalau weak base, you akan dapat concentration of OH-. Tapi kalau kat sini, if you want to find pH, you know that pH dia punya formula ialah negative log concentration of H3O+. Tapi kalau you ada nak kena cari pH of weak base pun tiada masalah. You just need to find the concentration of OH- so that you boleh cari POH. POH ialah negative log concentration of OH-. And lastly, you kena gunakan formula pH is equals to 14 minus POH to find pH value for weak base. Okay, and then kenapa dia special untuk weak acid dengan weak base? Because weak, asal ada keyword weak kat depan ni, okay, weak acid ke weak base ke, mereka akan dissociate secara partial. Okay, dissociate partially. So kalau diorang dissociate partially, diorang dah tak gunalah arrow sehala. Diorang tak guna dah. They don't use this arrow. Makanya mereka akan use this reversible arrow. And also, bila diorang dissociate partially, they need pertolongan H2O untuk mereka dissociate. Okay, and then kalau you nak tahu walaupun mereka ni weak acid ataupun weak base, tapi if you can calculate dia punya dissociation constant in terms of weak acid dengan weak base ni, okay, boleh dah dapat the value of Ka dengan Kb ni, because the larger the value of the Ka ataupun the Kb, the stronger the acid or base. Okay, just now we have learned that tadi ada statement bagi tahu, dia kata kalau value of Ka atau Kb ni dia tinggi, bermaksud the stronger lah the acid ataupun base tersebut, walaupun dia adalah weak acid ataupun weak base. Okay, as you can see here, these are all the weak acids and weak bases. Okay, yang macam terkenal weak acid, HCN, okay, HNO2. Get yourself familiarized with this, and you can see lah bila dia nak buat dissociation tu, dia buat dissociation partially. As you can see here, mereka semua memulakan water bila nak dissociate. Okay, so bila you tahu this is acid, makanya water ni akan jadi base. Alright, so acid pasangan dia ialah conjugate base. Okay, base adalah pasangan dia conjugate acid, and ni adalah value dissociation constant of the weak acids as follows lah. Okay, and then next, okay, macam C6H5COOH pun adalah weak acid. Acetic acid ni pun adalah weak acid yang famous juga. Okay, so get yourself familiarized with all of this. And then next ialah weak base. Okay, yang famous weak base selalu digunakan ialah NH3. Kalau NaOH, strong base. NH3 adalah famous weak base. Okay, And you can see as follows lah. And then group of amines pun adalah weak base juga. Sama juga, kalau weak base dia akan dissociate partially, maka dia memerlukan water bila dia nak dissociate. Kalau let's say this is base, H2O ni akan jadi acid. Okay, so kalau base pasangan dia ialah conjugate acid, acid pasangan dia ialah conjugate base. Okay, and this is the weak base dissociation constant for the following. Okay, and then if you look at dia punya value of Ka atau Kb ni, lagi besar value dia, the stronger the weak acid ataupun weak base tersebut. Okay. Okay, next Miss nak ajar kamu macam mana nak buat Ka dan Kb expressions. You kena ingat ya, Ka dengan Kb ni is specifically for weak acid dengan weak base respectively. Okay, because kalau let's say you jumpa strong acid dengan strong base, previously kita nak calculate pH of strong base, mana ada Ka atau Kb langsung kan. So kiranya kalau you jumpa strong acid dengan strong base, memang you takkan nampak lah dia punya nilai ataupun value Ka dengan Kb. Okay, this is only special for weak acid ataupun weak base. For example, if let's say you nak buat Ka expression, Ka ialah weak acid. Okay, Miss tulis kat sini lah, weak acid dissociation constant. Let's say if you have a general reaction of a weak acid, di mana Ha ni ialah weak acid. Okay, and since that you want to dissociate a weak acid, it will be done partially. So bila partially, you akan dapat reversible arrow and you memerlukan water untuk you dissociate the weak acid. Okay, so since that Ha ni ialah weak acid, therefore H2O ni akan jadi base. Okay, dia macam tu. H2O ni dia boleh jadi base atau dia boleh jadi acid. It depends on apa yang dia pair with. Faham tak? Okay, so sekarang ni kalau let's say Ha kamu adalah weak acid, okay, makanya pasangan dia, produk dia ialah A-. Betul tak? Because according to the Bronsted law theory, acid dia akan donate proton. Dia akan hilang proton. So A- ni, produk yang dah hilang proton ni, kita labelkan dia sebagai conjugate base. Faham? Okay, so weak acid pasangan dia conjugate base. Base pasangan dia ialah conjugate acid. Sebab kenapa? Sebab this base dia according to Bronsted law theory, dia akan jadi base kalau dia terima proton. As the product dia terima proton, so the product ni akan jadi conjugate acid. So how can we build the dissociation constant? This is just how, kalau if you look at subtopic 6.2, K ni ialah equilibrium constant. Tapi chapter 7, K adalah dissociation constant. Okay, tapi tak kisahlah, untuk you build the K expression, it's always gonna be K is equals to concentration of product to the power of product bahagikan concentration of reactant to the power of reactant. Tapi dengan syarat mereka mestilah di dalam phase aqueous ataupun gas. Tapi kalau let's say you belajar chapter 7 ni, takkan ada phase gas langsung lah. Dia hanya akan ada phase aqueous only. Alright, so next, you tengoklah, you buatlah, build the Ka. Ka is equal to concentration of product. Okay, product ada conjugate base A- and conjugate acid H3O+. Divide by concentration of reactant. Reactant ada weak acid Ha saja, just because H2O ni dia dalam pure liquid. Okay, you kena remember, kalau let's say you nak build a dissociation constant ke equilibrium constant ke, kalau phase tu adalah pure liquid, you jangan include dalam the expressions. Faham tak? Okay, so that's why pentingnya untuk kamu tahu all of the phases when you build the dissociation equation. Okay, sebenarnya yang biasanya lah, kebiasaannya all of it are in aqueous phase except H2O sahaja. Next, how can you build a Kb expression? Kb ni ialah weak base. Okay, sorry. This is a weak base dissociation constant. For example, if you have a general reaction of a weak base, given this is a weak base. Okay, if this is a weak base, B ni ialah weak base. Bila dia nak dissociate, dia sangat memerlukan bantuan water and dia akan dissociate partially, therefore dia akan ada arrow reversible. Okay, so bila dia perlukan bantuan water H2O kat sini, if this is a weak base, H2O ni akan jadi acid. Okay, dia flexible tau H2O ni. Okay, you kena ingat kalau weak base pasangan dia ialah conjugate acid. Okay, if this is a weak base according to the Bronsted-Lowry theory, dia adalah base sekiranya dia accept proton. So if you look at the product, this B already accepted a proton. So that's why product of this weak base adalah BH plus ni is a conjugate acid. Okay. Lepas tu kalau let's say acid H2O ni, according to the Bronsted-Lowry theory, acid ni adalah spesies yang donate proton. So if you look at here, dia punya produk dia hilang proton. So this product OH minus, we consider it as conjugate base. You kena ingat macam tu je. Weak base pasangan dia conjugate acid. Acid pasangan dia ialah conjugate base. Macam tu. And then as usual, if you want to build K expression, tak kisahlah A atau B, it must be concentration of product to the power of product, bahagikan dengan concentration of reactant to the power of reactant, and the phase must be aqueous. Okay, and then next when you want to build the KB expression, concentration of product kena berada di atas, which is we can see the product here ialah conjugate acid BH plus and conjugate base OH minus. Okay, bahagikan dengan the concentration of the weak base. Concentration of H2O ni kita boleh ignore just because of dia is in liquid, pure liquid phase. Faham tak? Okay guys, previously we have learned how to express Ka and Kb if given a general dissociation reaction of weak acid and weak base, right? But right now I want to explain the relationships between Ka and Kb, acid-base conjugate pairs. Okay, if let's say you ada acid-base conjugate pair of NH4 plus and NH3, so the dissociation of both species in water will be, okay, kalau NH4 plus adalah weak acid, okay, NH3 adalah weak base. Cumanya bila mereka ni masing-masing dissociate in water, obviously because this is weak acid, this is weak base, dia memerlukan air untuk dissociate partially. Okay, you kena ingatlah kalau weak acid, tak kisahlah dia weak ataupun strong acid, if any acid dia akan menghasilkan conjugate base. Okay, if acid according to the Bronsted-Lowry theory adalah spesies yang akan donate proton. So you boleh tengoklah kat sini ada 4 H, di sini ada 3 H. So the product will be the conjugate base. Okay, pasangan acid adalah conjugate base, and since that this is acid, H2O ni akan jadi base. Okay, and then pasangan base adalah conjugate acid. Bila you nak build the Ka expression for this weak acid dissociation reaction, it will be concentration of the product, which you have here NH3 and H3O plus, bahagikan concentration of reactant, which you have here is NH4 plus. Okay, H3O ni kita tak payahlah, kita ignore je because it is in pure liquid. Next, for weak base NH3, this is a weak base. So according to the Bronsted-Lowry theory, base ni adalah spesies yang akan accept proton. So you tengok dekat produk dia, dia accept 1 proton. Daripada 3H jadi 4H. So this product is considered as conjugate acid. You kena ingat ya, base pasangan dia adalah conjugate acid as the product. Okay, and then since that this is a base, H2O akan jadi acid. Okay, so acid pasangan dia ialah conjugate base. Bila you nak build the Kb expression for this weak base dissociation reaction, it will be Kb is equals to concentration of reactant, kat sini ada OH minus and concentration of NH4 plus, bahagikan dengan concentration of reactant, kat sini ada NH3. Okay, H2O ni as usual, since that is in a liquid phase, so we can just ignore it. Alright, so how can we relate Ka, Kb acid-base conjugate pairs ni? So tadi kita dah build Ka expression previously and also Kb expression if given weak acid NH4 plus and weak base NH3. Okay, so kita kalikan sahaja Ka and Kb expression that we have built before, and apa benda yang sama tapi in different punya fraction ni you boleh lah cancel out. Okay, macam NH3 dekat concentration of NH3 dekat Ka boleh cancel out dengan concentration of NH3 dekat Kb, concentration of NH4 plus dekat Ka pun boleh cancel out dengan concentration of NH4 plus dekat Kb expressions. Okay, and therefore yang tinggal hanyalah concentration of H3O plus and also concentration of OH minus, where we know that kalau the multiplication of concentration H3O plus dengan OH minus will be equals to Kw, and then we can conclude here the relationships between Ka and Kb is equals to Kw, and we know that Kw ialah ionic water dissociation constant, and it has a fixed value which is 1 times 10 to the power of negative 14. Inilah dia relationships between Ka and Kb, which dia akan menghasilkan Kw with this value. Okay. Okay, so next kita nak mendalam sikit lah. Miss nak terangkan pasal weak acid. Weak acid, as we know that it will be partially ionized in aqueous solution. So at equilibrium, basically aqueous solution of weak acid ni dia akan ada non-ionized acid molecule and its conjugate base. So this is the non-ionized acid molecule. Ataupun senang cerita, this is a weak acid. So weak acid bila dia dissociate partially in water, dia akan menghasilkan conjugate base. Disebabkan oleh dia telah donate proton, so produk tu tak ada proton, dia menghasilkan conjugate base. And this is the Ka expression, di mana concentration of the product divided by concentration of reactant Ha, weak acid sahaja. Okay, and if you want to find the percentage of the acid dissociate, it will be equals to the concentration of acid dissociate times with 100 divided by initial concentration of the acid. Okay, previously we have learned a statement saying that kalau Ka value ni semakin tinggi, bermaksud the acid will be stronger, although that is a weak acid, tapi dia akan the strength of the acid tu is stronger lah. Okay, that means the more ions are present in equilibrium relative to the weak acid ataupun to the unionized molecule. So nak katanya kat sini, kalau let's say dia punya Ka, the weak acid dissociation constant tu is greater than 1, therefore the acid to the completely ionized, and actually the acid will be strong acid. Okay, so tapi jarang-jarang lah nak dapat more than 1, and then the percentage of ionization of weak acid will be decreased as the molarity of the solution increase. Okay guys, so let's get to the real deal. Let's look at this example. This will come calculate the pH of 0.1 molar acetic acid CH3COOH given the Ka of the acid is 1.8 times 10 to the power of negative 5 molar. Okay, again, nak calculate pH. Apakah formula pH? Formula pH ialah negative log concentration of H plus ataupun concentration of H3O plus. Okay, macam mana nak tahu H plus ataupun H3O plus? It depends to the dissociation of your acid ataupun base lah. Tapi kat sini dia bagi acid. Okay, so sekarang ni macam mana you nak tahu if this is a strong acid ataupun weak acid? Kalau strong acid senang saja, you dissociate completely and then you buat stoichiometric comparison between reactant dengan product, then you will get the pH. Macam tu sajalah. Tapi it is different when it comes to weak acid. Okay, how do you know that this is a weak acid? Because the clue here, the biggest clue here ialah dia bagi Ka. Okay, this is the biggest clue. Okay, because Ka ialah weak acid dissociation constant. Okay, and also the other clue ialah kalau you tengok dekat table, ada Miss ada bagi tahu previously table of weak acid, kan Miss suruh get yourself familiarized with weak acid kan. So CH3COH ni adalah one of the most famous weak acid lah. Okay, so macam mana nak kira pH of this weak acid? Okay, yang ni assumption ni let X is equals to concentration of H3O plus form or concentration of CH3COH dissociated ni is not that important yet. Yang ni yang paling penting. You kena build weak acid dissociation equation. Okay, macam mana you nak dissociate weak acid? You ingat balik, anything yang weak akan dissociate partially, maka dia memerlukan water untuk dia dissociate. So this is how it goes. CH3COOH plus H2O, and then since they dissociate partially, dia akan ada this reversible arrow. And okay, kalau acid adalah spesies yang akan donate proton according to the Bronsted-Lowry theory, so the product akan hilang hydrogen. Okay, so this product we call it as, kalau this is acid, this is conjugate base. Okay, if this is acid, okay, this will be conjugate base. Okay. And then H2O ni dia flexible. Kalau dah pasangannya acid, this must be base. Okay, so kalau base according to the Bronsted-Lowry theory, dia akan accept proton. So produk yang accept proton ni we call it as conjugate acid. Okay, so dia menghasilkan H3O plus kat sini. Persoalannya, macam mana you nak cari concentration of H3O plus supaya you boleh kira pH? How? So this is when you need to build a rice table. Okay, this is something not new to you. You dah pernah hadap dah rice table ni dekat chapter 6 kan? Okay, so sekarang ni macam mana nak build rice table in terms of concentration by referring Ka. Okay, so sekarang you buatlah rice table. R stands for reaction. Okay, I stands for initial concentration. C stands for change. E stands for the concentration at equilibrium. So kita masukkan reaction yang berlaku. And since the H2O ni adalah pure liquid, so we can just totally ignore the H2O. Okay, initially, the concentration of the acetic acid ialah 0.1 molar. Okay, you tak perlu letak M kat belakang because dia letak M kat sini. And then, kalau produk, memang kita always assume initial concentration of product ialah 0. How about the change? Macam biasalah, kalau let's say dia adalah reactant, dia negative X. Kalau let's say dia product, dia adalah positive X. And therefore, ini akan menjadikan the concentration at equilibrium for CH3COOH ialah 0.1 minus X. Okay, and then concentration of CH3COO minus and also concentration of H3O plus ialah X sahaja, positive X. Okay, because kosong plus X kan. Okay, tapi kita yang paling penting ni, kita nak tahu ni concentration of H3O plus. So we need to find the value of X supaya kita dapat the value for the concentration of H3O plus at equilibrium so that we can find the pH. Okay guys, next, how can we find the value of X? Okay, so first thing first, dalam soalan dia bagi nilai Ka, di mana Ka adalah sebanyak 1.8 kali 10 kuasa negatif 5 molar. How can we find the X value? Is by building the Ka expression. Okay, this is a general Ka expressions. Okay, but in this case kita dah ada situation yang diberikan ni, di mana kita boleh terus build the Ka expression based on this reversible chemical reaction is equals to concentration of products CH3CO minus kalikan dengan concentration of H3O plus bahagikan dengan concentration of reactant CH3COOH. H2O tak payah masukkan since that it is in a pure liquid phase. Okay, lepas tu kita masukkanlah previously kita buat rice table and we know that the concentration at equilibrium untuk each of these species apakah. So you masukkan saja di mana concentration at equilibrium untuk CH3COO minus and H3O plus adalah X and concentration at equilibrium for CH3COOH at the rise table previously ialah 0.1 minus X. Okay, and then you equalkan with 1.8 times 10 to the power of negative 5 molar. Next, since Ka ni is small, how do you know that it is small? Because dia times 10 to the power of negative 5. Kalau let's say if this times 10 to the power of negative 4 and ke atas lah, negative 5, 6, 7, itu dah kira small. So we can assume yang nilai X ni is small. So kita boleh assume yang 0.1 minus X is 0.1. Okay. Yang ni this kind of assumption pun Miss dah ajar dalam subtopic 6.2. Okay. So once kita tahu yang Ka value ni small, we can assume 0.1 minus X is equals to 0.1. So kita boleh dah terus calculate lah. Dia jadilah Ka is equals to X times with X bahagikan dengan 0.1 equals to 1.8 times 10 to the power of negative 5 molar. Okay, lepas tu you just square rootkan saja. You bawakan ke sini, you square rootkan the answer and you can find the X value is actually 1.342 times 10 to the power of negative 3 molar. Okay, tapi tak berakhir kat situ. So after you dah dapat the value of X, you substitute the value of X dekat the rise table so that you dapat value for the concentration of H3O+. Okay. So kat sini kita tahulah since X is equal to 1.342 times 10 to the power of negative 3 molar, kita tahu at equilibrium concentration of H3O+ adalah X. Therefore, ni you kena tunjuk lah ni. Therefore, concentration of H3O+ is equals to X, which is equals to 1.342 times 10 to the power of negative 3 molar. Dah boleh calculate pH ke belum? Boleh. Okay, sebab pH ni ialah is equals to negative log concentration of H+ or H3O+. Since that kat sini dia dissociate, dia menghasilkan H3O+. Jadi kita gunakan formula pH is equals to negative log concentration of H3O+. Because ni weak acid, so dia dissociate H3O+. Kalau dia strong acid, dia dissociate H+. Sebab dia dapat buat dissociation completely. Okay, this is different because this is a weak acid. Therefore, we can now get the pH value for this weak acid. CH3COH ni adalah 2.87. Alright, so let's look at the next example. Dia bagi kat sini propionic acid HC3H5O2 with a concentration of 0.01 molar was prepared and it was determined that the acid ada 3.7% ionization. So dia nak suruh kamu cari Ka for the acid. Okay, kalau Ka, nanti you kena buatlah Ka expression. Tapi first thing first, what can you do is you cari the concentration of HC3H5O2. Okay, how can you after they dissociated? So how can you do it? So kita tadi dah belajar pasal ionization percentage kan for weak acid, di mana concentration of acid dissociate bahagikan dengan concentration of acid initial times with 100. So concentration of propionic acid initial ialah 0.01. Okay, and then to find the concentration of HC3H5O2 yang dah dissociate, kita tahu dia punya percentage of ionization ialah 3.7%. Okay, so senang cerita 3.7 bahagi 100 kalikan dengan 0.01. So now we can find, we can get the concentration of HC3H5O2 yang dissociated adalah sebanyak 3.7 times 10 to the power of negative 4 molar. So kiranya concentration of HC3H5O2 yang left at equilibrium ialah sebanyak 9.63 times 10 to the power of negative 3 molar. Okay, so sekarang kita buat assumption. Let the concentration of propionic acid dissociated is equals to 3.7 times 10 to the power of negative 4 molar. Kiranya this will be equals to the value of change. Yang concentration at change yang X value kan. So kita boleh assume X value is equals to 3.7 times 10 to the power of negative 4 molar. Okay, so apa yang kita boleh buat once we have assumed the X value is equals to the concentration of propionic acid yang dah dissociated tu, which is sebanyak 3.7 kali 10 kuasa negatif 4 molar. Next that we can do is we can do the rise table. Okay, so you buatlah rise table di mana reaction di atas ialah the dissociation equation of propionic acid. So how can you do the dissociation equation? Kita tahu propionic acid ialah weak acid. How? Because dia suruh kamu cari Ka. So dah salah propionic acid ni is a weak acid. So you have to bear in mind, kalau weak acid dia akan dissociate partially, so dia memerlukan bantuan water. And also bila dia dissociate partially, dia akan menghasilkan reversible arrow macam ni. Okay. So this is the propionic acid. It's a weak acid. So bila dia dissociate partially, okay, since the acid according to Bronsted law theory akan donate proton, so dia akan hilang proton dekat bahagian produk. So as you can see here, so bila dia hilang proton, this is dia punya produk lah, C3H5O2 minus. And H2O ni, since this is acid, dia akan jadi base. So dia akan menghasilkan conjugate acid H3O+. Sebab dia dah terima proton kat situ. So how about the initial concentration of the propionic acid? It is given in the question, which is sebanyak 0.01 molar. H2O ni is something that we can ignore since that it is in liquid phase. Okay, so anything that is in the product, we can just assume dia punya initial concentration dia is 0. How about the change? Okay, kalau change ni, kita tahu kalau let's say dia dekat bahagian produk, bahagian produk dia positif, bahagian reactant dia negatif kan. So in this case, this will be negative X. Okay, this will be positive X and this will be positive X juga. Tetapi since that we have assumed X value is equals to concentration of propionic acid yang dah dissociated, how do we find this out? Kita dapat this value after kita kira percentage of ionization tu untuk cari propionic acid concentration yang dah dissociated. So that's why kita dapatlah dia punya value ni, kita boleh assume dia adalah X value. Di mana you masukkan teruslah the change, the concentration at change untuk propionic acid in this case ialah negative 3.7 times 10 to the power of negative 4 molar. Okay, concentration of change at both this product, since it is plus X, so it will be plus 3.7 times 10 to the power of negative 4 molar. Next, at equilibrium, okay, you just tambahkan sahaja dua benda ni. Okay, so kalau 0.01 tambah tolak 3.7 kali 10 kuasa negatif 4 molar, you will get 9.63 times 10 to the power of negative 3 molar. Okay, how about these two things? Kalau kosong campur 3.7 kali 10 kuasa negatif 4 molar, it will be 3.7 times 10 to the power of negative 4 molar. Okay, next, dia nak suruh kamu cari Ka value. So you kena build Ka expression. This is the general Ka expressions. Okay, so based on this situation, the Ka expression will be equals to the concentration of both products C3H5O2 minus kalikan dengan concentration of H3O plus bahagikan dengan concentration of reactant C3H5O2, and then you masukkan nilai concentration at equilibrium for each of the species. And then nanti you akan dapatlah nilai Ka adalah 1.42 kali 10 kuasa negatif 5. Tiada unit, okay? Because Ka ialah dimensionless. Okay, so next is about weak base. Weak base pun dia partially ionized in aqueous solution. So at equilibrium, an aqueous solution of a weak base contains a mixture of non-ionized base. Okay, this is a non-ionized base because basically dia tak buat apa-apa lagi. So dia tak ionize lagi lah, tapi once after dia dah dissociate partially, dia akan menghasilkan conjugate acid yang ionic. Okay, and then since that this is a weak base, bila dia nak dissociate partially, dia memerlukan bantuan water. Okay, untuk dia dissociate dan dia akan hasilkan OH minus as the product. Okay, and then this is how you build Kb expression from this general base dissociation equation. Okay, and then this is kalau let's say the weak base dia ionized, this is the punya formula di mana percentage of the base dissociation is equals to the concentration of the base dissociate kalikan dengan 100 bahagikan dengan concentration of base initial. So let's look at this example. Dia bagi tahu base dissociation constant for ammonia Kb. Kb adalah base dissociation constant. Ammonia adalah NH3. Okay, Kb untuk NH3 ni 1.8 times 10 to the power of negative 5 molar. Dia suruh kamu calculate the first thing, dia suruh kamu calculate the concentration of OH minus ion. Next, dia suruh kamu cari pH. And the third one, dia suruh kamu cari the percentage dissociation of equilibrium if the initial concentration of NH3 is 0.15 molar. Okay, so this is a weak base. How do you know that this is a weak base? Because ada key dia kat sini, dia bagi Kb. Okay, so you kena tahulah kalau Kb, this is the hint untuk bagi tahu NH3 ni ialah weak base. So therefore you nak cari apa-apa, bila you nak dissociate NH3 ni, you have to dissociate it partially. So, macam mana nak cari the concentration of OH minus ion kalau diberi Kb? Okay, first thing first, kita dah tahu tadi weak base tersebut ialah NH3. How do you know that it's a weak base? Because dia bagi hint kat sini nilai K. So macam mana kita nak dissociate weak base? We have to dissociate it partially with the bantuan of H2O. Okay, so this is the dissociation equation untuk weak base NH3, di mana dia memerlukan H2O untuk dia dissociate partially. So dia akan dapat reversible arrow kat sini. NH3 after dia dissociate, dia akan menghasilkan NH4+ because base kan according to the Bronsted-Lowry theory, dia akan accept proton daripada 3 proton jadi 4 proton, and then akan ada ion positif lah kat situ. Okay, and the next H2O, since that this is the weak base, ni akan jadikan H2O ni sebagai acid. So acid H2O, makanya dia akan donate proton, so that's why dia akan menghasilkan produk OH minus. So kat sinilah kamu dapat OH minus ion kat situ. Okay, daripada dissociation of NH3 secara partially. Okay, so this is your main aim kat sini untuk cari concentration of this OH minus. So how can we find the concentration of OH minus ni? Kita boleh buat rise table. Okay, kita dah buat reaction kat atas ni, and then kita buat rise table. Kita buatlah initial concentration, change, and concentration at equilibrium. Okay, so initially dia ada bagi tahu tadi the concentration of NH3 adalah 0.15. Okay, untuk H2O ni, since it's liquid, so we can just ignore everything about H2O. And then NH4+ dengan OH minus, since mereka berada di bahagian produk, so we can just assume any initial concentration at products ialah 0. Okay, how about the change? Kalau reactant dia minus X, kalau produk dia akan jadi plus X. And then therefore at equilibrium, concentration of NH3 will be 0.15 minus X. And concentration of at equilibrium untuk NH4+ dengan OH minus masing-masing X. Okay, because kosong plus X, X kan. And then next, how can we find the X value? Because we want to find this. This is your main aim, okay, to find the concentration of OH minus ion. So how? Kita build Kb expression, okay, di mana concentration of product at equilibrium berada di atas, concentration of reactant at equilibrium berada di bawah, and kita tahu nilai Kb berapa, which is 1.8 times 10 to the power of negative 5 okay, molar. And since you nampak negative 5 value kat sini, kita tahulah Kb ni dia punya value is very small, so we can assume 0.15 minus X is equal to 0.15. This one bila you buat assumption, you kena show. Kalau tak, macam mana examiner nak tahu you buat assumption ke tidak? And then nanti you bawa lah naik 0.15 kalikan dengan 1.8 kali 10 cos negative 5, and then you square rootkan the answer. And finally, you can get the X value here, which is 1.64 times 10 to the power of negative 3 molar. Since that the concentration at equilibrium for OH minus ialah X, therefore we can conclude the concentration of OH minus will be 1.64 times 10 to the power of negative 3 molar. How can you find the pH? pH dia punya formula dia ialah negative log concentration of H plus ataupun H3O plus. Okay, tapi tadi kita buat weak base dissociation equation. We couldn't find any H plus or H3O plus punya concentration pun, but the only thing that we have ialah concentration of OH minus ion. So how can we find pH if we have the concentration of OH minus ion punya information? Don't worry, you just need to remember this formula, di mana pH is equals to 14 minus POH. So you need to find the POH dahulu. POH ialah negative log concentration of OH minus. Once you dah dapat the value of the POH, and then you gunakan this formula, pH is equals to 40 minus POH untuk masukkan you masukkan nilai POH kat situ, dan after that you pun akan dapat dah nilai pH value. Okay? Because kenapa penting untuk kamu cari nilai pH? Because only pH value boleh determine the acidity or basicity sesuatu compound tersebut. Okay, pOH value tak akan determine the acidity or basicity satu compound, because we only have pH scale, we don't have pOH scale, and pH scale is from 0 until 14. Is 1 until 14, and then kalau let's say towards 14 it is most basic lah, so this is quite a basic solution here. Okay guys, next, how can you find the percentage of dissociation at equilibrium if the initial concentration of NH3 is 0.15 molar? Okay, so this is the formula untuk cari the dissociation percentage. Okay, di mana X value kena bahagikan dengan concentration initial times with 100. How can we find the X value? We already found it when we did the solution yang untuk first kali tu. Okay, where after kita dapat rise table and so on, and kita dapat jumpalah nilai X adalah 1.64 kali 10 kuasa negatif 3 molar. Okay, concentration initial dah dibagi dalam soalan, which is 0.15 molar, kalikan saja dengan 100, therefore you will get the percentage of dissociation at equilibrium if the initial concentration of NH3 is 0.15 molar is 1.09%.